Good afternoon. My name is Briscoe from Rezatec. I'm joined by my colleagues at the front here today. Our project was to look at using Earth observations, specifically using Sentinel-1 SAR data, to make the monitoring measurement of peatland integrity for Scottish Water far more cost-effective, far more cost-efficient within their organisation. I apologise, my slides are a bit light on images, unlike everybody else's, so sorry about that. So just to set the scene a little bit, there's quite a lot of peat in the UK. You may not realise it. A lot of it's in Scotland, but there's also a lot in the northwest of the country, in Wales, down in southwest of the country in Northern Ireland. Scottish Water have probably the largest amount of peatland from where they draw their water. So I'm talking about their drinking water. They've got around 450 catchments, and about 50% of those contain peatland. So that's quite a lot. There's about 12,500 square kilometres of peatland. That's an awful lot to monitor, certainly with kind of ground resource only. So you can see how the application of Earth observation data to cover vast areas of land is very attractive. And the opportunity, I guess, as I said, is to incorporate the use of Sentinel-1 data, not least because it's open access, therefore making this far more of a cost-effective solution, but also in terms of innovation to try and apply this to a new environment. Just looking at, I think, a study of about 47 of Scottish Water's catchments indicated that something like 97% of them have been damaged by drainage ditches. This is what causes a lot of peatland to dry out. Essentially, that's what we're looking for. We're looking for poor integrity of peatland because that results in dissolved organic matter entering the water, results in the release of carbon. Also, there are implications for maintaining water, as in flood risk. So it's a very attractive opportunity to be able to identify where the degraded peat is in order to put in place effective restoration programs. The payback being costs less to treat the water. It's very expensive to put in place water treatment works, but not least there are benefits around compliance, Water Quality Framework Directive, and also around the deployment of ground resources. I mean, Scottish Water can't cover 12,500 kilometres square on a particularly regular basis. So what we're aiming to do is really tell them where to focus by giving them a kind of course level analysis of where the high risk areas are, and then do more of a drill down into what's causing the issues within those areas. So essentially we used what we call our landscape intelligence portal, and we derived a number of different data products that rolled up into the data service. So I'll talk about those in a bit more later on. And the idea was really to help them direct where to put in place restoration effort, but with the most intelligent use of existing resources and reducing the cost for the benefits that I mentioned. So there was an innovation piece here in how we understand and use the Sentinel-1 data. I'm sure you're all familiar with the Sentinel series of satellites. I mean, the Sentinel-1 is focused on SAR, Sentinel-1A and B, and that gives us a kind of, will give us a kind of 6-day update on data. So we've been incorporating that into the way that we've built the application. Scottish Water have been trialling during the feasibility study, been trialling our results as they've gone along and validating our outputs, and you know we're pleased to say that our estimates have been validated where they've sent field staff out. Of course, there's always room for improvement, which we would aim to do in a further phase, but we've proved the feasibility in the first instance, I think. The way that we work, the way that we present this information is in a kind of online portal. So the information is there 24/7, and we can update that when required. And the approach that we took was to look at different components of the landscape that makes up the peatland integrity. So first of all, we looked at the basic landscape, contours, woodlands, that sort of thing. And then we started to understand first of all, we looked at the peat depth. So we worked with data from the James Hutton Institute to understand peat depth across the region. And then using our algorithms, we then rolled that up across the wider study area, basing it on similarities of hydrology and topography and other environmental factors. And then we measured the soil moisture using thermal data, I believe from Landsat data. And again, used our same approach and rolled that out across the study area. So we're starting to build up component maps in order to roll them up into a kind of combined peatland integrity index. Other areas that we looked at were the floristic indicators. So we looked at 8 different types of vegetation, so 4 positive and 4 negative kind of grasses, sedges, that would give an indication of the moisture within the peat and the general health. And then importantly, we also looked at the drainage, so the anthropogenic disturbances, which are the main activity in terms of restoration. And so we looked at, instead of manually digitizing each one, we looked at an index across, a density index across the different areas, which proved to be as useful. So we roll all these up into what we call our peatland integrity index, and from that we can then apply a secondary level of analysis, which is a water quality index. So once we know where the risk of dissolved organic matter from degraded peat, we can then look at its proximity to water, understanding the flow accumulation of the area, and then additionally add a water quality index, which is going to then help with a restoration recommendation. Embarrassing, this is our only picture, but this is an example of the output portal, and you can see it's presented in a kind of very visual kind of risk-based map. And then along the left-hand side, you've got the different data layers you can turn on and off, and you can drill down for more information. We deliberately have this as a very easy to understand environment, but the more technical data is there if you want it. You can drill down and find that degree of information. So this is what they've been using. Scottish Water and the field staff have been using out to direct their field activities and to validate our estimates of peatland integrity. So Scottish Water was really our key user in this project, but as we went through, we realised that, and certainly we would look to do this for phase 2, incorporate organisations like James Hutton Institute, and probably look to talk to SNH as well, Scottish National Heritage, because there's obvious benefit in what we do here, and possibly even with forest research as well within Scotland. And the feedback has been, I won't read out this quote, but essentially it's around helping with better deployment of ground staff and actually seeing a cost efficiency in that respect, and all of this feeding up into the overall water quality directive that Scottish Water employ. So the impact has been, and bear in mind this is feasibility studies, we've just done it on a smaller area than we would propose to do in a phase 2, where we would roll it out across the entire area. To date, the kind of validation work that's gone into place has seen far better use of ground resources, which lowers costs in terms of sending field staff out. We expect most of these are kind of expected because we've only just delivered on the project in March, but we would expect this to feed into much wider activities in terms of managing the overall peatlands across the entire catchment. And this is what we'd intend to do as we extend it in the next phase. In terms of a business model, we have a kind of online subscription approach to the way that we would sell the data. That will be our consideration, and that allows us to do routine updates as well of the data as and when required. For something like peatland analyses, a lot of the initial analysis is then going to inform the restoration plan, but what you'll probably want to do is monitor the success of your restoration efforts. Now, things like vegetation indicators are going to take several years before you see any difference, but things like soil moisture and other more shorter term outputs would be quite usefully recorded on a updated basis, especially as you're trying to justify your restoration activities to all sorts of stakeholders. And we provide kind of secure access to the portal, and we can provide it to lots of different user types, not just in the private sector, but in public sector, but in private sector as well. So in terms of next steps, we feel we've successfully managed to take Sentinel-1 data and incorporate it into our analyses. I think there's more work to be done, but in the first instance, we feel that's been a success. By very fact of having been recipient of the grant, that's enabled us to undertake not only the product development, but also bring on board, Scottish Water for this project, which gives us a fantastic kind of reference case study and some nice proof points. And then moving into the next phase, we'd like to roll it out across the wider area, the 12,500 square kilometres, and we've been incorporating automation into the processes in order to be able to do that. We'd also like to incorporate a degree of predictive modelling into what we do, which would be a slight extension to the capabilities. So this might be around modelling for the reduction in dissolved organic matter, carbon, as a result of restoration activities. And then also, as I mentioned, involve other stakeholders, but ultimately, as a commercial proposition, we could roll this out not just to other public sector organisations, not just water companies, but also to private sector, and not just in this country, but things like the European Water Framework Directive relates to all EU countries. So I think there's a lot of opportunity there to commercialise further. So in conclusion, I think what we have set out to do in the first instance, and certainly Scottish Water, who send their apologies they couldn't be here today, certainly very pleased with what we've done so far. They're seeing tangible cost efficiencies in terms of managing and monitoring the peatland. That gives them a far better understanding of the relationship between what happens on the land and the quality of the water, and ultimately there's a payback model in that it's going to reduce the amount of cost and effort to treat the drinking water. And it also helps them far better in their restoration prioritisation efforts. So we're looking forward to hopefully being successful in phase 2 and rolling it out further. Thank you.
Are there any questions for Phil and his team in regards to this project? Questions?